I'm Kevin Heggarty. I work at the IMT Atlantique in Brest in France in the optics department, and I'm Professor of Optics. Our main role is to parallelize the write process, writing with lots of spots rather than single spots, to increase the write speed of the whole process. Well, it's mainly through the parallelization to reach write speeds that people can't write at the moment, and being able to fabricate things much faster. We reach industrial application level rather than just a research level in a laboratory. So it's aiming to take it out to industry by writing faster. Difficult question, because there are lots of things that are interesting. We're pushing the technology, and we're working with people who have knowledge that we don't have, and putting it together, because we have knowledge they don't have, and putting it together is brainstorming. We're doing over the coffee breaks, to be honest, is one of the things I like most, and I think that's where we'll be making things that are really new and a step up on what's available currently. The main thing is learning more about multiphoton photoplotting, especially the photochemical aspects, and also some of the design for especially the 3D structures. We make 2D diffractive structures ourselves, but not close to the wavelength, and there are partners here who have knowledge and experience in the part that we don't know, so I'm definitely learning things from that part, and we'll be looking at designing software and using their software to design structures that we wouldn't have been able to design in the past. Definitely, yes, definitely, especially on the design side of things, and from discussions we've had even today, I think we'll be looking at different ways of parallelizing using different devices, which I've been thinking about for a while. We have no experience on, and some of the partners do, and so we'll be definitely learning from that side as well. The main impact of what we're doing will be speed, but also we are involved in quite a few applications where we work with Stellantis, so we're closely linked to them. We know the sort of applications they're looking for, and so we hope to be able to push the system designer, the device designers, in a direction that will be towards something we know will be useful and that we know we can make, because make fast, because we can't do everything. There will be constraints on the design, and I'm greatly enjoying working with the design partners to finding something that they can design that will give the optical function we want and that we can fabricate. We'll be using it ourselves because it will give us new capacities to fabricate and design structures that we couldn't so far, and so I'll be using that with our conventional and historical applications in security holograms, automotive and various others, so I'll get myself more wider than that. What we're starting to be able to fabricate is interesting people working in the bioscaffold domain, and we're already in contact with people in medical and biological domains, and that's something very new for us, and we seem to have a solution to some of their problems. So I'm looking forward greatly to working in that field as well. I think the two things. One is we'll be able to generate, perform optical functions which weren't possible before, and on an industrial scale, so we'll be able to find new applications. The second is that the way we do it is faster and less polluting than the historical silicon etching, e-beam writing, so I think we will have a smaller footprint from the ecological viewpoint. Of course, it hasn't done yet, but there's good potential for having a smaller ecological footprint for doing the same things or doing things that just weren't possible before.